Hello, it's my great honor to introduce to you my fellow Java champion and Professor Ken Fogel, who's going to be talking about how his views of teaching Java have evolved. I guess Ken needs no further introduction, so just take it away.
Thank you very much, Kay. I was having fun with Kay just before we started. I have a number of his books, and he has had a great influence on how I taught and what I've been teaching in Java over the years. So much so that I even wrote a book that I don't think anybody buys. But hey, I can say I wrote a book and it impresses people. Okay, let's talk about how my views have changed. I'm going to just switch to nice full screen there. Great. Don't have to see, don't know if you can see me. I just see my screen. So let's go ahead. So a little bit about who I am. I'm not going to spend time here. You can freeze frame this later. Enough to say that I have taught computer science for 31 years, Java since the year, I think, 1998. And
Ken, sorry to interrupt you, but
yes,
we see your PowerPoint thing, not the actual presenter screen.
oh, okay, interesting. So let's see if I can fix that. There's always a technical thing. I'm going to change the screen I'm sharing. So I'm going to stop sharing. Okay. How is that looking?
Now we still see your
See the PowerPoint.
yeah.
Good. So if I say, okay, what do you see?
Same thing.
Same thing. Interesting. Okay, so let's just change how I share it. Always a hiccup somewhere. Dum-da-dum. Okay. Entire screen. Oh, I know what's happening. Okay.
Okay, now we see an infinite screen. And
Okay.
all right, excellent.
Can you see the slides now?
Yep. Okay,
Oh,
take it away.
good. So, as I said, that's who I am. What did I teach? When I was at Dawson, I taught in the final year of the program. So these were students who had already done 2 years, and I would lead the project courses. And I had a great time, and 31 years was long enough, and move on to other interesting things. Small warning, the code you're going to see here is all based on preview features. Specifically, I'm right up to Java 23. If you want to play with any of the code here or in reviewing the material want to work with it, remember to include the VM parameter --enable -preview. You can say it in your Java command line, or if you're working from an IDE, just remember to add this as a parameter to the runtime. So, simple question, what is programming? Well, it's step-by-step problem solving. I figure we should all be amazing programmers because every morning we wake up and we have problems to solve, like, where's my slippers? And of course, that leads you to a sequence of events like looking down at your feet and so on. Programming is about that step-by-step approach. Unfortunately, over time, the methodologies presented to us seem to get more and more complex. Let's begin here with some spaghetti programming. This is a slide from a really old presentation I used years ago. And if you're wondering what strange language that is, that was probably GW Basic from Microsoft. And the GW stood for Gee Whiz. So they didn't have a big marketing department in those early days. This would have been from the early 80s. But it was a nice, simple program, right? it was considered spaghetti code, right? You've got all those numbers for your lines. There's the thing we've all been taught to fear, the go-to command, unless, of course, you do machine language, but that's another story. But this little program would allow someone to play this silly game until such time as they guess the number. So it'll go on infinitely, but as soon as they guess it, and hopefully they stay within 1 and 10, they're going to get a result. So I know when I saw this, I went, gee, this is really easy. Of course, there's a problem with this, and that is as complexity increases. So then we all moved to structured programming. Here is some really old C code. And, we'd have to do our flow chart. There was, all kinds of things. We had to figure out, okay, all the different methods. Definitely not impossible. The structure was nice, but was it really structured? Because there's no definition of what structure means. That has to come from experience. But of course, it can only get worse at this point. And I've decided to rename object-oriented programming to be confusion-oriented programming. And that's because there is so much work that we have to do to handle this. So here's that same game. I've written it in my best object-oriented approach. So we've got a bean for the data in the game. We've got a class that runs the app. We have the actual game code. And you can see it just gets worse and worse and worse in terms of the complexity, the boilerplate, all kinds of things we have to add. So the question is, do you care? Does it really matter what you're using? And of course, the answer is you shouldn't. We're too hung up on this. Spaghetti, structured, or OOP, they're just organizational decisions. And any one of these, whether it's the spaghetti, the structured, or the OOP, can quickly become poorly organized code. And for the same matter, you can write a spaghetti program that, well, works really well, is well organized, is even, I hate to use the word structured, and it solves the problem. So why do I start with this? I start with this because when I started teaching, I was too focused on the approach, right? I obviously never taught, well, I can't say I never taught spaghetti programming. I remember doing a summer camp teaching 14-year-olds how to program Apple IIs with Apple. So I probably did teach spaghetti coding for a while, but we'd spend a lot of time talking about structure, talking about OOP, and it kind of obscured in my mind what we're really trying to do, which is solve problems. So Java, of course, became very quickly one of the most widely used languages in the world, right? It was more object-oriented than C++, right? I taught C++ for a few years. I thought it was really cool, but there was so little you could do with it other than solve math problems. Java became or had a massive standard set of libraries, right? Go back to for the line above, an idea that I forgot to mention. You couldn't do GUIs naturally in C++. So Java was the way to, create this new world of GUI applications. You had this massive set of standard libraries. You wanted to talk to a database, there was a standard for it. There were numerous tooling options. Pick an IDE, whether it's Eclipse, IntelliJ, NetBeans, or a plain text editor. And to me, what was amazing as a teacher was this write once, run anywhere. I can remember giving a class to students where some students had a PC, some students had a Mac. And when you're teaching C, well, now it gets complicated, right? Running C on a Mac is usually different from running it on a Windows box. But with Java, as a teacher, I didn't need to care what computer either my lab had or what computer my student had. As a side point, I found it interesting that I had very few students who used a Mac. I know things have changed, but that always fascinated me. I expected a lot more. They were all into Windows. I blame Call of Duty for that. And of course, Java worked on numerous platforms, whether it was desktop, whether it was server, mobile devices. You could write Java code for almost anything and still can. But sometimes time is not gentle to us. In this particular case, we notice that Java has kind of fallen out of, popularity. So what's getting people? What's turning them off? Well, the need to download and install 354 megabytes. That's the size of the latest full installation of Java 23 on a Windows machine. Now, I find this fascinating that for many people this is a problem. Yet, if we go back to my silly Call of Duty, you take a look at all these games that you can download onto your PC from either Steam or EA or Xbox. They're hundreds of megabytes long, and don't think twice about it. But running an installer for Java for many people is a daunting task. Then you need to download and install an IDE. You don't. You can work with a regular text editor, but there are so many details that you have to be concerned about that, as I used to teach Java, we used an IDE in the first class, right? Because it was the only way to deal with these details that got in the way. Another thing that has turned people off to Java is that we read about all these enhancements, but more often than not, these enhancements address the needs of senior developers, not the early learner, not the beginner. Yes, Java was popular in high schools at one time, and of course it was popular because it was more fun than C or C++. But then simpler languages like Python came along and they became friendly. Whereas much of the work on Java was to deal with those more complex issues, needs of the senior developers. Excessive boilerplate, we'll come back to that. And then there's all these strange terms like object orientation. Okay, polymorphism. Eek. Inheritance. I'm going to get money. Mutable, immutable. Is this a science fiction movie? And then the stream. Why the heck does the language want to know how I pee? Anyways, I'm confronted with all of this that I'm expected to quickly pick up. So in 2022, Brian Getz, and if you're not familiar with him, he's one of the senior developers, members of the Java development team, released a document with this title, Paving the On-Ramp. And it was a design note for a project he and the team at Oracle were working on called Project Amber. In general, a project designed to simplify parts of Java. And in this paper, Brian proposed simplifications for teaching Java. A more tolerant launch protocol. Not sure what that is. We'll see it in a moment. Unnamed classes. Oh my God, that's unheard of. Predefined static imports for the most critical methods and fields. And one that I've left out here is the idea of importing modules, which is kind of exciting because rather than importing one library at a time, you can import a whole batch of them. So the more tolerant launch protocol. Everybody gets numbers in this world of how systems work. So started off with JEP 330. As it's enhanced and improved, it's JEP 458 now. These are still in preview, and I'm sure there'll be one more numbered version before it's finalized. But this addressed that issue of launch protocol. So I took this from the documentation for 458. that the typical process of running a program is you edit it, then as a separate step, you build it, and then you run it, right? JEP 458 and the idea of, the simplified launch is to say we edit and we run. So we've gone from this 3-part, right? First compile, then you're able to edit it, then compile it, and then run it. And we move it to just one single line. Notice that we have to add the extension.java so we can make this work. But now your code is compiled and it executes in a single line. What this has done to me in the teaching, and I don't do much of it. I'm teaching just one course currently at Concordia University, but it is a beginner's course. And we're coming up to the 3rd class, and I haven't even talked about IDEs yet because I don't have to. Because a regular text editor can provide the simplicity somebody starting out needs. Let's take a look at the classic first program. Of course, because I'm Canadian, it's not Hello World, it's Hello Moose. So this is, that first class, I would come in, I would put this up on the board, I would run it, and everybody would go, oh. Wasn't too exciting. They'd yawn a lot. And then I'd have some work to do, like, what's that? What's that? What's that bracy thing? Ooh, look, there's the word public again. What's that? What's that? What's that? What's that? Square brackets, huh? What's that? Remember, we're dealing with people who've had little, if no, exposure to programming. Oh, there's that funny brace again. System, out, print line, that thing in quotation marks. Well, I would find myself at the beginning of a course spending more time telling people, don't worry, be happy. I'll explain this later. We'll get to static in week 4 and system.out.println. That will do next week. And I would ask students to play with code and force them, I didn't have a choice, to use things they weren't familiar with. This idea of all these, there's the decorations, the boilerplate. Now I was someone who came from C++, so of course this made all, perfect sense to me. Didn't have any issues with it. But if you've never encountered this, then it's like, all I wanted to do was say, hello, Moose. Yes, what? So let's take a look at the dramatic changes. And I should point out, if you didn't watch Kay's presentation yesterday, he did an excellent one on small Java programs, and he used a lot of this to demonstrate how we can use Java to solve some problems in a nice and quick and easy way. But it also applies to teaching. So bye-bye to public, static, void, main, string, args. Oh boy. So there's 6 pieces of information there, right? There's access control, object or no object, return type, method name, parameter type, parameter name. And I tell everybody, ignore them all. They wanted to know, what was I hiding from them? Was there something? Finally, we get a main method that makes sense. This is the latest definition of this. I encourage you to look this up online, read the documentation. These simple source files and instance main methods. So, what does Hello Moose turn into? Well, first of all, we get to meet our new main. Notice there's no public, there's no static, there's no string square bracket args. I'll tell you something silly. I actually prefer string ... args, but that's just me. So this is it. This is main. It's even more exciting when you realize as this is set up at the moment, you can actually use this in any Java program, not just the, paving the on-ramp specialty. Oh, yes, let's give it a round of applause. No more, decorations. How about we want to print out hello moose? Well, we just have a print line. Gonna system.out. It's all second nature to us. But again, having to explain those dots, well, system is a class and out is a static subclass, or is it static? And then print line, well, that's got to be a well, you don't want to do that. You just want to say, okay, let's print something. Ooh, fireworks. Hooray. And then when we put it all together, we have a valid Java program, right? Anyone can now open up an editor, type this in, and you'll notice there's no class. It's simply the name of the file. So if I put this in a file called bob.java, I would run it by saying java space bob.java, and it will compile and execute. Any errors might show up in my coding, but I have that simplicity. And I'm going to have to mention the P word at this point. That's Python. A lot of schools have abandoned Java because of Python's simplicity. And I really believe that the difference now between Python for a beginner and Java for a beginner, from this simple point, yes, we still need a method to put code into, but we're not confronted with all that OOP and boilerplate. So here's this program we saw at the beginning. It was my example of spaghetti code, right? Silliness. So I said, okay, let's rewrite this in what I'm going to rename Spaghetti Java. So here's our same program. And although it looks a little bit longer, that's because I've respected all of the formatting so that we could probably put print line too small up here or put the too large on the same line. But if we take a look at the lines that do something, compared to the GW basic, this is really about 3 lines longer. So suddenly I'm able to go into the course, go into the class I'm giving now, and just deal with making things happen, dealing with the commands, and so on. So what was going on here? When we looked at the code, we did not see any import. Yet, it was clear. I'm just going to back up for a moment here. We can see the fact that we are creating an instance of the random object. We're working with integer. There's a class in there. But where's the import? Was an import necessary? Do we have to consider it? Well, we don't. And that's because when we create a file without a public class, whatever, and we just immediately start with void main, we are given an implicit import, the java.base. We're also given currently 3 static imports in a new preview library called IO, and this is where our print line, and our read line is coming from. A change is coming up, and it's a small one. Currently, this IO class is implicitly imported like Java base, but it's being moved around. It'll have no effect on how it works, but your programs will now only need to implicitly import the Java base module. There's no longer a need to implicitly import, meaning the system doesn't have to add that for you when you're not looking, in code going forward, starting with Java 24. So this has no effect on your coding, but it's coming. Side effect of this is we'll be able to easily use I/O methods in any Java application, so that suddenly we have a print line and a read line for anything. When I'm teaching, and one of the things that I've always thought important was data. I remember reading my first book on C++, where they described object-oriented programming was all about inventing new data types. Well, I have to admit, this is not an opinion I've changed. This is an opinion I've maintained. And what you're looking at on this slide, this strange, thing with, well, there's a plug for my book, something about total serial, and then the enter guide for some kind of car, I assume. I would present these to my students, and I would ask them to examine the description and determine what variable types will be needed. Right? So we've already talked about int and double, but I try and have them work as soon as possible, modeling. I won't call this complex, but more than just saying, what's your age? I wanted them to analyze and look at this. And what I have them do is simply code this. Now, it used to be I'd have to teach them what a bean was, so that, okay, we're going to code it in a bean, and that opens up another, as they say, kettle of worms, kettle of fish, never quite sure which animal. It's going to drive people crazy. So we begin by simply in a file going, string title or string publisher, int pages, and they would create the list of all the things they identify. And we do it this way because if I want to take this any further, if I want to perform any operations, I can simply take this and drop this into my void main. Well, at this point, students can kind of make things happen. So we get to the very first program I have all Canadian students do, what you need to get a job at the Canadian Space Agency, a countdown. But remember, this is it. This is the entire program. No imports, no public classes, no public static, no string arms, right? Count backwards from 10 to 0. There's our for loop, and we can talk about the for loop. I think we should be talking about for loops before we talk about public and class and all of that. That's another reason I'm excited about this approach. So we've looked at the beginnings. We've seen how simple it is to write hello. And as I said a moment ago, let's not talk about the boilerplate. Let's talk about Java logic, syntax. So we have a sequence logic, selection logic, iteration logic. These are the keys to every language. This is what I'm doing now. This is where I'm focusing, right? The lecture I have this week, I do it every Thursday night. We're going to be looking at, making decisions, how we loop without having to concern ourselves with visibility. Now, I guess in some cases I can make the decision, well, I could have kept the old way, but just make everything static. Well, when you make everything static in a Java program, and we're not talking about libraries, we're talking about everything, right? The whole thing is one big static piece of code. Well, there's a name for that. It's called C programming. You want to code that way, it's time to go back to C. But if you want to evolve, if you want your students to evolve into object-oriented programming, let's focus on the details. And here again is a change for me. I was always one of those objects first. Boy, in that first class, we were making objects. And I was quite proud of myself. But well, it took me a while to realize that my students were just mimicking what I wanted them to do. They never gained the understanding. They didn't see its purpose. They can see the purpose of sequence, selection, iteration. Things happen, but not the rest of that object-oriented orientation, what I'm now calling confusion-oriented programming. So here's the master plan. When I started teaching, I was hired at Dawson College in a program where the primary language was COBOL, a language I knew nothing about. Apparently, that's why they hired me, because at that point in my career, I was already coding commercially in C and C++. That's what they wanted to teach. But I remember one day they told me, "Ooh, we're short a teacher. You're going to have to teach the introductory COBOL course." And I kind of panicked a bit, and they gave me a whole bunch of notes. And one of the things I came across was this particular diagram, which was meant to describe how most mainframe programs were structured. Main was simply the entry point, and then you had an input component, you had a process component, and you had an output component. And as we move to PCs, languages like Pascal, C, C++, C++. I even programmed in something called PL1, but that's for another story. We kind of forgot this, right? We kind of pushed it aside and just started making lists. Okay, I need to do A, I need to do B, I need to do C. I always felt, and it's something that it struck me again only after watching my students, that at the highest level, I call it the master plan, this remains what every program is doing, whether it's an interactive GUI program or if it's a batch type program, just do something and then you're done. It still comes down to input, process, and output. With that in mind, what's really important when we talk about code? Well, there are two, and these are principles you've all seen. But these are principles that once I've done with the syntax of the language, this is the next stress point, not stress, the point that I, make for the students. Single responsibility principle. And that leads to its method time. With single responsibility, we can start saying, okay, what are you trying to do? You want to get information from a user, you're interested in a value, it has to be in a specific range. There's your definition of a method, right? You don't want everything, or you don't want a method to do, well, the item is to say you don't want it to do more than one thing at a time. That's never quite possible, but you want to make sure that this particular method is, responsible for just one very precise aspect of the code. And so this is how I present it. We move to what I call high-level design, and now we're talking about separation of concerns. And that, of course, is really the buzz for its class time. Separation of concerns is something I express to my students as a way of, understanding, or a way of determining what you need in the way of a class. Right? Methods are pretty easy. Oh, I need to ask for this, I need to ask for that, I need to do this calculation. But when we look at separation of concerns, now we can say, okay, what are the concerns? And, You know what? The concerns go back to that first diagram. Sorry, I'm going to go back. There's my separation of concerns. It would seem to me that in most object-oriented programs, hard to believe that I learned this because I almost had to teach COBOL, but in most object-oriented programs, at the very least, you're probably going to need 3 classes to handle this. And then as process becomes more complex, you add more classes to assist in the process or the output or the input. So these are the two, architectures that I stress. There's certainly a lot of them out there, but single responsibility, separation of concerns. Your early learners need to understand what that means so that they can apply it properly. I've thrown this in here because, I don't know, to me, this is the greatest enhancement to the Java language of everything, although it's kind of silly. Let's take the switch, right? We inherited the switch from C. And the switch itself is based actually on the underlying machine language of most CPUs. And therein lies the problem of once a case is true, the rest are true. Why? Sorry, that's just the way it is. And then there's those breaks, right? I need a way to get out. I'm sorry, I've hated the switch since the first time I saw it in C. If you want to go back in time, the best switch remains a switch that was in Visual Basic 6. So look that up, look up a switch in that. But let's take a look at the modern. The switch now falls into 2 categories, expression or statement. This is an expression, and it matches the other. In the original switch, I had to keep saying value equals, value equals, value equals. But in the new switch, well, my case, they look the same. We introduced the dash greater than, and we're basically saying, look, there's the information to stuff in value. I don't have to keep repeating value equals over and over again. This is, to me, tremendous. As we could in previous switches, I can have code, I can do all kinds of other things in there. But what I know is at some point, a value is going to come out of this, and it's going to be assigned to that double value we see at the top. I'd rather teach the one on the right than the one on the left. Now, the bad news, you got to teach the one on the left. There are still so many organizations that have code based on this original switch that somebody learning the language has to be familiar with it, especially if they intend to go into software development. On the other hand, if someone is looking to learn about programming, see what it can do, whether they're going to be a professional developer or not, that's not the case, then quite frankly, I can't imagine why you'd ever teach what's on the left and only teach what's on the right. Maven. So up until this point, my approach is the students are using a text editor and they've got a terminal window open, and that's how they're compiling and managing their code. At some point, you're going to want to add a feature to the language, something that is not included in the Java SE. Now we have to get it. I've been teaching long enough that I remember having a class on, okay, let's all open up our browsers and go and search for the driver for MySQL. Oh, here it is on the MySQL website. Okay, download it. Okay, now you've got it downloaded. So now we have to put it in the class path. But wait a minute, the default class path is in the Java installation. So now I need to put it somewhere and add a dash class path item to the Java command line so it can find what I wanted. Well, as you can imagine, I dislike this approach. That was not the way to do it. Again, we're adding complexity to something that isn't directly related to solving the problem. And so that's where Maven comes in. And so I know all of you are using IDEs, and hopefully you're using Maven in the IDE for your build system. It's the only way as a teacher I can tell to my students, you want to use IntelliJ? Go ahead. You want to use NetBeans? Go ahead. Just do the projects in the Maven format, and it doesn't matter what I'm using. So there's the power of Maven. But of course, Maven's getting your files, getting your libraries. This is something that students need to learn early on. It's not an advanced second level or third level topic. And then there's unit testing. The statement on the right, I tell this to a lot of people, and it's still, I'm just freaked out by it. Had an opportunity to meet with a CS professor at a university here in Montreal, and we were talking about what are they using. So, well, the first thing they told me was they use Java 8. Well, after we stopped crying, the next thing I asked them was, what about unit testing? When do you teach unit testing? And he said with a straight face that it was not given in the undergraduate level. It was only a graduate level topic. And although this program had numerous options, web, game, business, engineering, it was only taught in the engineering option. All the other options in their program that taught programming, and Java was still the primary language throughout the program, did not consider unit testing significant. I'm here to tell you, in terms of the approach, my first level course will end, the last topic is unit testing. How do you know that brilliant method you wrote works? Before I used unit testing, that's what you use main for, right? You put something in main to test some code. Well, that's a horrible way to do it. Plus, you have the tendency to leave tests behind that you didn't mean to. Unit testing is a first level topic. It is not an advanced topic. And then finally, a final thought. Consider Lego as your inspiration. I would teach my students how to build, blocks, how to build components that could perform specific tasks. There's where we start thinking of single responsibility. We group them together. We have separation of concerns. Lego is a great inspiration, even if our code isn't quite as colorful as what we see there. So I hope you've got some insight into what I'm doing in teaching and possibly considered something else. I'm going to join you back because I can't see anybody. I'm going to join you back in this regular studio, and I look forward to any questions you might have.
So we already have a few questions. Let me
there we go.
take
Yeah,
your screen up. That have accumulated. Although there was a lot more banter than questions here. I'm glad the audience had a good time. The one was more of a comment that with Java 24. One can't just do println anymore, but nowadays one has to say io.println again. So you still don't have to import anything, but it is those 3 extra letters. So the println, the unqualified println, lasted for a very short time.
Okay. If I can say something here, if you're going to use IO in a standard classed Java program, you're right. You have to say io.print. I'm not sure if you need the IO dot in classless files. My reading suggested you didn't, but I don't have a 24 build to test that.
Okay, you absolutely do. So, and the idea in the end is consistency, that you have to use integer.parseInt, math.pow, and so on. If you want to get rid of one of those things, you use a static import that you can do, but those are not automatic.
Good.
So that's the way that someone was dubious about that other college professor, probably someone with less experience of college professors than you and I have, and said, what was that? When that person didn't want to have anything to do with JUnit? Was that a
Okay.
recent thing, or was that like 30 years
Okay.
ago? Or?
If you click on the comment, everyone will be able to see it.
Yeah, I just can't find it.
Oh, it's just the comment itself. You just click on it.
I know. I'm trying to go through the banter and find the comment, but I remember it.
So the question was, who was this professor who told me?
Not so much who. You're not supposed to name names necessarily, but yeah, when was it?
Oh, you're not going to like this. 4 months ago.
Oh, okay, that sounds bad.
And well, again, I won't mention names, though I'd really love to embarrass them terribly so they stop doing this, but I do have to stay on friendly terms with them, so I won't. But I don't think they're necessarily unique. And I'm looking at some of the comments, and I see Bill Fly writing, I introduced JUnit test classes with first assignment for students to test their assignment. I think that's great. I worry that now you're dealing with a little overwhelming them. They've written some code, they want to see the output, and now you have to have the test rig. So that's why I don't do it in the first class, but it's still part of the first course. Because once we get to Maven, it becomes a little more sensible how to explain where JUnit fits in, but they still don't make it easy. There's good old Surefire in there. What else have we got?
Well, actually, let me put a comment there. One reason not to do JUnit right from the get-go is also that if you start out with the kinds of programs that you do, where you do a bunch of input, a bunch of output, those are not all that easy to test with JUnit. What I actually do is I have a much simpler testing framework where students are supposed to do some computation, and then below that, they're supposed to print out what they expect the answer to be. And the framework just checks whether those two lines have the same content. And that actually works pretty well. It forces the students to get thinking about testing without having any machinery. And then, of course, soon after, JUnit does come in. And the other thing with JUnit is it works so much better when you do have some classes, right? If the functionality is in classes, those become much more testable than just a simple program.
Yeah. A problem that I've always encountered working with students over all these years, especially beginners classes, is this assumption that if you get an answer, then it worked.
Oh, yes.
Their feeling is if you did something wrong, it's going to crash. It's going to give you an exception. And then, of course, what the heck is an exception, right? I think I'm exceptional, but apparently I'm not if I use that term. But still, you have to recognize, what's happening in your code, and you have to ask yourself, does that answer make sense? Right? You give students a problem, and I always give students a problem to calculate loan payments. And it just takes one simple thing, forgetting that an exponent has to be a negative number. So you always get an answer. And as I say to many of the students, I really want to work at your bank. I want to borrow money from your bank. Because if I borrow $5,000 for 5 years at 5%, $26 a month seems like a reasonable payment.
The other situation where the students now always get an answer is when it's not them who write their solutions, but their chatbot of choice. Yeah. And so you would think, do you see that with your students?
I haven't seen that yet. Right. So, I left the full-time classroom 3 years ago, just as AI was starting to take off. I teach this one online course, again, a first level Java course. And we've talked a little bit about it, but it's so far, I find it relatively easy to recognize when something's been written by
Hmm.
AI, and that's obviously going to get harder and harder. So, what I will frequently ask students is, can you stand up in a classroom when we were in person and tell me what your code does? Right? Give me a line by line.
Right.
Or
Oh, I've
how
done
about,
that in online courses too.
yeah.
And actually, the other students were always very interested what was going on the screen of one of their fellow students, much more than they were ever interested in my screen. So it's worth doing.
Cool. What other, I don't think we have any questions.
Not so much, but I wanted to dig into the Maven thing a little bit because I have not heard a lot of people using Maven in an introductory course. I mean, of course, later on, um, you might see it, but so do the students find it overwhelming? Is it easy for them? Because now you're going to have to do exactly what you didn't want to do on day one, right? Tell them, don't worry about all the details.
Well, there's no question about that. And it's why I wouldn't do it in a first course. This becomes the icing on the cake in week 10. These are all right
Yeah.
now, the courses are 10 weeks, 3 hours a week.
Mhm.
But they've worked with enough code. And at this point in the course, we've also moved to an IDE. And so IDEs are really good in generating the POM file. I should make that as a project to figure out a way to simplify it, but you're right. It gets them a bit, but I'm very focused. Why are we using Maven? There's only ever two reasons. One, Java FX.
Okay.
We need to bring that in. And the other
Mhm.
is Maven. And we don't do anything else with it because we're not talking to databases yet or, doing JSON or talking to servers. Maven becomes critical in later courses. But
Yeah.
you got to do GUIs because people want to see GUIs. And I hate to say this, but Swing is ancient history. It's convenient, but I was really disappointed when Oracle decided to move Java FX out of standard Java. I keep hearing rumors that it's coming back in, but the
No.
reality is, yeah, okay, that's what I thought. You've got to bring it down. And then,
Yeah.
and when I started teaching, the gold standard for GUIs was Visual Studio for C++ from Microsoft. They had this amazing tool for designing GUIs. And in the Java world, there were numerous attempts to copy it, but we're never anywhere close to that until we hit Java FX, until we hit Scene Builder. And suddenly I was no longer envious of Visual Studio.
Mhm.
But to do this, yes, we've got to have some Maven there. But
Yeah.
keeping it to the bare minimum, it's just to get those
Yeah.
plugins.
Yeah. The other thing I like about Maven is, like you say, then students can use whatever IDE they want because IDEs are good about reading a Maven file.
Mm-hmm.
All right, that's all pretty interesting. So what do you see like looking forward in the next few years? How is teaching going to change, you think? Teaching computer science. Is it going to be pretty much the same, or are we now at complete revolution because AI is going to eat all that?
Well, as someone who got into programming because I thought it was really cool, I love the problem solving. I also recognize, and I hate to say this, but we're coming to the end of the line. To me, there's no question that the majority of software, I'd say within the next 10 years, will be AI generated. And what our profession will become is AI code evaluators, right? Does
Hmm.
the code we've asked our AI to do doing the task? And even that's going to be harder and harder as AIs realize that they can use all this super complexity in the language and turn out code that we as humans could not understand. But a company's going to go, gee, it cost me $20,000 for that code. I don't have to hire a team of 6 programmers at 200K each to do this. Can't deny that's happening. But if you're going to evaluate AI code, then you really need to know how to code yourself. So I can still see us having CS programs and students learning to code and then getting jobs evaluating AI code.
So you think the AI is going to get good enough? I mean, right now it's very obvious that they can solve student level problems.
Mm-hmm.
And so when I talk to professors, they say around the third semester or so, then the AI is just not good enough anymore. And students are actually struggling with that because they haven't developed like the necessary muscle memory to then take over the coding. But you think the AI is going to at some point just be better than a bachelor's degree student?
Oh yeah, no, I'm very confident in it. I have never subscribed to the thought of or the feeling that AIs will develop and become sentient and all of that. That I don't see.
Mhm.
But in terms of the sophistication, when I started working with AI a little bit, I could get it to recognize my dog in pictures, right? And I thought this was the most amazing thing, but there was no career path in doing that. But we see it more and more every day. I find myself talking to my devices more than I ever did. I used to, type every question. I could be precise, but AIs now understand me. Whether that's good or bad, I don't know. I think it's good, right? I think it's great. I'll say one more thing about AI. It was a great line that said, right? I don't want my AI to solve my problems so that I can do the wash and clean the house. I want my AI to clean the house and wash my clothes. And I will solve the problems. I think that ship has sailed. We're all going to have a lot more time to clean the house.
Well, or to finally catch up with technology.
Mm-hmm.
All right. Well, we're approaching close to the top of the hour, so maybe we should call it a wrap so that everyone can join the next session.
Great, thank you. I've noticed some comments. Yes, I love the Head First books. They had a style. There was some comedy. They're definitely great, and there are a lot of great books out there. And modernizing the language, and that's the thing about Java. It is so dynamic that there are so many people working on whether it's JSPs, JEPs, the acronym of the week, to make the language better, reliable, trustworthy. Remember, if you're using a bank, there's Java. Thank you, Kay, for moderating me.
Okay. Well, talk to you later. Bye-bye.
Bye-bye, everyone.